Now, to summarize this lab, there are actually two parts. First part is the VectorGrid, where you can throw a projectile from the corner by hitting this shoot button, and then actually control the vector field, the wind, by adding the vectors either in a row or in a column. And then that's all you need to play. And as we talk about in the lab, you just have to complete all these tasks. Note, each of these is an individual task, not the steps. So, for example, the first one, you want to add the vectors so that cancel the initial row of vectors, so that shows nothing. Cancel a row of nothing, and then after that, when you successfully achieve that and make it 0, and make a snapshot and insert right here. Okay, right here you insert here, and then next one you put these vectors for 75, 45 degree. For example, put 75 here and 45 here, and then choose say row. Think about this row D or column D. You say row D or 3, and then they will add vectors here. So in this case, if you put it there, it will put this 75, 45, you collect all vectors like this. And then for the other vector as well. And then you add this vector, you need to put the same vector on another column and then add the other vector. So, and for this speeding up, it's give you some hint. The cannon shoot out this one, and then you put the wind or acceleration vector against it, and so that it will be going to here, reduce, and then they probably turning back, and then decrease speed, increase speed, and turning in different directions, making counterclockwise turns. So see object shooting here. Then if you have the wind blow this way and push, then it will go a circle like this. So this is counterclockwise. If something goes this way, and so the object moving this way, and the wind blow the other way, so then it will go, and this will be a clockwise. So, and it's not really a unique solution. You just have to make sure you know how to enter the proper vectors. Okay, and there's a lot of trial and error, and in the process, you can improve. Hopefully, that you learn the vector magnitude and directions specified with angles, make it with x-axis. All right, so and then this one, similar to gravitational field, is like the gravity. You think about the G is everywhere is the same. So you think about the whole field with the same vector, every row and every column, and then you shoot the cannon. It will go like a parabola like this. And hopefully you can make a video, a few seconds. Don't put a like 25 minutes video. This will only show. If it's too difficult, just give it up and make it one. Just make a screenshot of this. And the final goal, or actually, once again, these are not steps. These are separate works. And the last step is to successfully shoot all 3 of the target. Basically, you do whatever you want, you can, and just to play with it. In fact, and we are learning by playing. The second part is simply an exercise, and I will talk some about this in the class as well. But this is part of the lab because we're going to use one of the apps online. It may take maybe a very short time, maybe take a longer time. Therefore, I put that in the lab as a lab homework. So, and this first, you want to play with this app, which for the vector addition at the site, just double click this link, choose a 2D lab, which means adding vector. Basically, you can put in one vector this way, another vector, so A and B, and you can drag along to adjust direction, stretch, make it longer, pushing or to make it shorter, and then you press sum, and they will immediately create a vector that's, so this is the sum. So it's A plus B, and that's the sum vector. So then at the same time, they give you the components like this. So input this one, and input this one, and the output will be that one. Give you all the components. So it does this automatically. So you just play with this, and these are this particular example I made. And here we'll compare to what we have already learned for our hand calculation. So that's what I want you to do in this lab. And adding these two vectors graphically, that's exactly the same old trick I want you to do, but make sure you do it exactly. So head to tail. So for example, adding these two, I on purpose don't give it a name even. So this one, draw this one on top of this one, same direction, same length, so that these two supposed to be the same. Okay, although I already made a little mistake, this is too long, but the resultant is this one. Okay, so the resultant is about how many degrees? Go from here, I think is about 300 degree roughly. So if this is so then what is about is the magnitude, and its magnitude is about, so if that is 1.8 centimeter, so this one is 2.98 centimeter, this one is also 2.0 centimeter, and so this one is 2.8 centimeters, so this one is 2.9 centimeter. Resultant is 2.9 centimeter. So that's just guess. I want you to with a ruler, do it with a ruler. But then, of course, I'm just here, just give you some hint what you're supposed to do. Then next question is measure the components. As in our exercise last week, we do these two vectors. So I would say the first one is 1.9 centimeters, and 0.5, so that's 0.5, and then this one is negative, no, positive, and 1.0, and then negative 2.0. So this is components. So this is Vx, Vy. So by components. Now, as we will learn in the class, adding two vectors, you can use graphical method as above, just find out. And you can also adding the components separately. So x plus x, y plus y, so 1.9. So 1.9, okay, 1.9 plus 1.10, you get 2.9. So then 1.5 minus 2, so it's negative 1.5. So it's negative 1.5. So this is the resultant vector in components. So that's this part. So now, and then I want you to use this online facility to above, which is this facility here. If I click this link to add this. Now I use this online facility to check our answers. So, but with this time, because the scale is larger, I have to use millimeter instead of centimeters, so it should be larger. So the smallest units is millimeters. So this one, 1.9 centimeter is 19. For example, A is my A, 1.9 centimeter, and 0.5 centimeter is this one. And that one, this one is -20 over there, and you can just move around. And so -20 and -20. So you can just drag the vectors here. You can have another vector and so on. So once you have this and you click this sum, so this is the resultant vector. Immediately you can have the resultant vectors components over here. Actually is 2.8 and 1.5. Write it down. So 2.8 and 1.5. So that's the resultant vector. Remember, it's written up here. It's written up here. So immediately, so you click here, you give components and resultant vector. So you can see that you can use the graphical method. You move here. It's exactly the same. So I mean, head to tail, this plus this, you will get this blue one, the resultant. Okay. Now you click the vector. Once again, where you draw this vector really doesn't matter. Length and directions. Length and directions. So A plus B, and this, the blue one, the dark blue one is the sum. So that's the sum. So you can see it matches with the head to tail. So if you from here to here, and then from tail of first one to the head of last one is the sum. Or you can do this way too. So if you go that way, tail of first one, head of last one, you go from here, and you see from tail of this one to head of that one is also the same. Or you can do a parallelogram between here and there. You will see the parallelogram is still, the diagonal will be this. Or you can do the parallelogram by putting this together like that. And you can see this parallelogram, this goes to its diagonal parallel. Can you imagine the parallelogram? You get the same answer. So now from my calculation, the resultant of these two, so since now is in millimeter now, is 2.8 negative 1.5. So 2.8 negative 1.5, and the angle, you can click here to see the angle. So if you click here, where? And its angle is, yeah, you click over here to see the angle. So that is negative 28. The angle is negative 28. Well, if you go in 360 minus 360, so negative 28.2 plus 360. If you're on a positive number, it's 331. So it's 331 degrees. So 331 degrees. So that's the addition with this app. So now go back to what we are doing here. And so you do what you end with the app. That's right down here. 2.8 and negative 1.5. If you compare with these two, this I get from the app, and see, very close. But that is basically, I just guessed. This one 2.9, negative 1.5. This is 2.8. Apart from some error, that's just human estimating error, and they're the same. And also, what is the magnitude of the angle? The magnitude is Well, I deleted. Then you can, the magnitude is something, here I let you do it. And you can also get from the calculation, basically how long is the resultant, the magnitude, and the angle. The angle is from the gap is 331 degrees. That's the resultant. And you can guess from here. It's also, see, I guess from here is actually 330. We're pretty close. All right, so hope this is helpful. We will get more of these calculations in the class and in the homework. Well, hope that's helpful with this lab. Have a good weekend. Bye-bye for now.